All right, so when we go through this, the endpoints, those are x1, y1, x2, y2s. So when we read this, it says endpoint at x is 7, comma, negative 3. So that's my x1, y1. Okay? And as you go through this and understand that because in my formula, x1 plus x2 is addition between two real numbers, I can flip-flop that to x2 plus x1, right? Make sense? And still give me the same thing. So if you were to call that point 7, comma, negative 3, x2, y2, that's fine. There's nothing wrong with that. I just see it as the first one, so I call it x1, y1. Okay? Now here's where we get into trouble, is that if we call that one x1, y1, people want to jump to this one, call this one x2, y2. But this goes with the midpoint, right? So that's why I introduced that subscript of m to remind myself that negative 8, where that should go in my formula, where the negative 12 should go in my formula. Okay? So now we just start plugging things in. After we've identified our formula that's going to kind of bind the whole problem together, we've identified the terms that we're going to use inside that formula to start plugging in, and then once I plug everything in, we should be left over with an expression or equation that is insightful on what we're supposed to solve for next. Okay? So as I do this, x sub m is negative 8. Y sub m, we said was negative 12, right? That's just plucking this stuff off from the description. X sub 1 is 7. X sub 2, nowhere in the description do they tell me what x sub 2 is. So I leave it as x sub 2. Y sub 1 was negative 3. Nowhere do they tell me what y sub 2 is, so I leave it y sub 2. If I look at those numerators, guys, 7 plus x squared, I could have flip-flopped that and it's been x squared plus, or sorry, x sub 2 plus 7, right? Same thing in the other one. Could have been y sub 2 minus 3. Or could have been x sub 1 plus 7 and y sub 1 minus 3. Okay, this meter property exists here, so we've got a little bit of freedom there. Now, what is going on here is that this is a set of rules that generates this ordered pair. Okay? That means this thing here should generate this x value. So I get an equation that I can write as negative 8 is equal to 7 plus x sub 2 over 2. That expression there, it's in the y position of my ordered pair. It should generate that y value. So I get another equation that says negative 12 is equal to negative 3 plus y sub 2 over 2. And hopefully then that gets us to algebra 1, right? Algebra 1 says if I've got a fraction in my equation, okay, or multiple fractions in my equation, I want to multiply everything by the what? Okay, the denominator. Okay, now be careful, because if we've got multiple denominators, we would want the one that is the smallest, right? Yeah, you guys remember what that is called? And so it's really not the denominator that's small, but it's the least common denominator, right? The one that is generated, the denominator generated by the common factors of all denominators. Okay? So I'm going to multiply. In this case, it's pretty easy because there's only one denominator here. So I'll multiply by 2. So I'll multiply this side by 2, and I'll multiply this side by 2. That gives me negative 16 is equal to 7 plus x sub 2. How do I solve for x sub 2 now? Subtract 7, right? Okay. So say I'm going to be negative 23 is equal to x sub 2. So that becomes the x value of my remaining endpoint. Come over here and find the y value. It's the exact same algebra. Multiply both sides by 2. So you get negative 24 is equal to negative 3 plus y sub 2. Then add 3 to both sides. Now they're going to ask you to write this as an ordered pair. So you're going to write this as negative 23, comma, negative 21. And I think it's important, guys, every time that we do something, especially if you're sitting at home working on maybe a take-home test, a take-home quiz, or a homework, or whatever, we're just trying to figure stuff out on your own. To do a problem, but then have some tool that will guarantee that my work has been done correctly. Okay, I want something to validate this. So I like to use 2 different programs. I don't know if I got this on your guys' computers at the first day. Did we put GeoGebra on your computers early in the year? Okay. I remember there was one class that I got it on and one class that I didn't. I'm going to grab GeoGebra. And what's really nice about this, guys, is I can tell to plot points real easily. Okay? I'm just going to say I want point X to equal, and then I just type in an ordered pair. So 7, comma, negative 3. Okay? I want point M to equal negative 8, negative 12. And as you kind of move out, you see that it does indeed plot those points, right? And then our solution was negative 23, comma, negative 21. So let's put that one as y, negative 23, comma, negative 21. And if I zoom out a little bit to get all those points in there, does it look like M is between the 2 endpoints, X and Y? Does that make sense? And if it's got to be a midpoint, then these 3 points should be collinear. Are they collinear? They all fall on the same line. Yeah. Okay. So that's some stuff there that might kind of validate the work. But even more, I can actually click on the distance tool here and click Y to M, and it'll actually tell me how far that is. Okay, so 17.49 units. And that'll be what we talk about. That's how that question in your homework that popped up asked you to find the distance. That's what you'd be looking for. And I'll show you how to do that today with a formula. If I go M to X, then I get 17.49. Is that confirmation that we've done everything correctly here? It put M exactly in the middle between X and Y. Okay? A tool that is a little bit maybe easier to use is Desmos. Okay, there's a lot of versions of Desmos. There's just a pure scientific calculator with no graphing, and then they've got their graphing calculator. If you want the graphing calculator, you just go to the website, and then you click on the red box that says Start Graphing. But all you got to do then is type in your ordered pair, so negative 23, negative 21. I can't remember what they were. 7, negative 3. And negative 8, negative 12. And then when I graph, so when I type them in as ordered pairs, it automatically graphs them over here. I just might have to zoom out to get them all there. Now there are ways, but it's kind of a pain in the butt to develop it. But there are ways to connect those with a line. I think there are ways to find the distance. Okay, but in this case, I think it's good enough just to visually look at that. And does it look like the green one's halfway in between the other two? And that will give me that confirmation that I think I'm doing everything right. Okay. For instance, if I've already gotten maybe the blue one, so the red one's the one we got, right? So let's say I did the work and I got something like negative 30
negative 21. That kind of looks misaligned, doesn't it? Okay, so that visual would help me tell, well, maybe I've done something wrong with my midpoint formula. I need to reevaluate. Okay, so my suggestion, use those things. Okay, I'll let you use those things on tests and quizzes and that kind of thing to check yourself. There are some things within GeoGebra that I'm going to kind of restrict from you on tests and quizzes, but Desmos is free game no matter what test or quiz we're on. Okay, I think that would be a benefit to you to develop an understanding for that. Do those types of questions kind of make sense then? How to address those? Those are usually the harder questions that people struggle on when we start talking about the midpoint formula. It's finding that other endpoint. That being said, guys, let's jump down to the distance formula. And right now, all you've got, I'll zoom out so you can see the whole thing here. Actually, no, I'm not. I'm going to zoom in just so you can see that. You just write down what that says right there. You've all taken tests where you've crammed for a test the day before, okay? Maybe the period before. And you feel, okay, I'm ready for this test. I'm going to take it. I'm going to do well. The minute you walk into class, everything you've thought about, everything you've studied and prepared for leaves your brain, right? You all been in that situation? Okay? Your memory is going to fail you. At some point, no matter what you've learned, no matter what you memorize, okay, it is going to fail you. Okay, you try to remember something. You might remember it for a day. You might remember it for a week. You might remember it for a year. It might be a decade. But at some point, the things you've memorized are going to fade away. Okay? If we can learn relationships, okay, the relationships that we learn are going to allow us to retain something in our memory a lot longer. Okay? And if it does start to fade, the relationship is what we can turn to kind of bring it back. Okay, so I'm going to give you that formula. I'm going to hesitate from saying memorize it. Okay, I want you to learn it. Does that make sense? There's a difference between memorizing and learning. Learning is a high-level thing. Okay, memorization, anybody can memorize something. Okay. But if you memorize something, chances are, in the short term, your memory is going to fail at some point, and you're going to forget it, or you're going to mess up the signs in this. There's a lot of plus and minuses. Okay, squaring things, subscripts of 2's and 1's. You're going to mess things up. Okay, so I want to try to learn relationships in contrast to trying to memorize things throughout the whole course. Okay, so what I want to do is instead of giving that to you and say, hey, that's what it is, I want you to know why that is a formula that works. Okay? And what's nice, so this is going to be a little bit similar to what we did yesterday with the midpoint formula, but what's nice about this is that you really know all the algebra and geometry that exists here that makes this really a smooth kind of transition from previous knowledge to new knowledge. So I'm going to take this point right here, and we'll call that A. So point A. I'm going to come up here, and I'm going to call this point B. Now, would you guys agree, so this is 0, 0 down here, this is my origin. If I move from 0, 0 to point A, would you guys agree that I have to move some x distance? Okay, so I'm going to call that x. Once I get, so I don't know what that, maybe that distance was 2, maybe it was 3, maybe it was pi, maybe it was radical 17, I don't know. But it was some distance x. Okay? Now, would you agree that at the same time, to get to A, I have to move a vertical distance? Now, again, I don't know what that is, but it's a vertical distance, and vertical distances are labeled with y's, right? Or we use y to represent vertical distances. So maybe that's 2 units, maybe it's 12 units, maybe it's radical 150, who knows? But it's y. Would you argue that we could do the exact same thing to get to B? Could I travel x units to get to B, and then some y units to get to B? Does that make sense, everybody? Now, here's the thing. If I say everybody look at x, are some of you looking at the black one? Or some of you looking at the orange one? So what do we need to do so that we can talk about them separately as different x's? We'll call that x sub 1, that one x sub 2, and then we'll do the same thing for our y's. Okay? So now if I ask everybody to look at x sub 1, we're all looking at the black one. If I say everybody look at x sub 2, we're all looking at the orange one. Okay? But those are distances. They maybe this is like 3 and that's 12. Who knows? Okay? But they represent just all those unknown values of our number line. Okay? So this point A is going to be located at x sub 1, comma y sub 1, right? That's the order pair for it. B would be x sub 2, y sub 2, right? We talked yesterday that no matter what segment we ever talk about in the coordinate plane, in the xy axis, it is always a hypotenuse of a right triangle, correct? So that black segment is a hypotenuse of some right triangle. I'm going to draw that right triangle in. So we'll continue to make the legs of that thing. So there's one leg. And here is then the other. That one red. This one blue. The legs of a right triangle are perpendicular to one another, right? When they intersect, we get this third point here, C. What is going to be the x value of C? How do I go from 0 to 0? How far to the right do I need to go to get to C? I just need to go x sub 2, right? How far up do I need to go to get to C? Y sub 1, right? So that's the structure of what we call the derivation, okay, the deriving of this formula, the creation of this formula, the making of this formula, okay? That's the setup. Now, that's a right triangle. What's the number one theorem, or maybe the number one property or rule that you guys have learned through the last, 5 classes of math that you've gone through? You always talk about this for right triangles. What's it called? Or what's the number one formula you guys have used with right triangles? Honor? What are you thinking? What are you thinking? Absolutely. A squared plus B squared equals C squared. What's that called? You guys remember Pythagorean theorem? Okay, a squared plus b squared equals c squared, right? Okay. Where a, you guys remember what a represents? That's a leg of your triangle. B is the leg. What's C then? You guys remember the C being the hypotenuse? Is that what we're going to say? Okay, good. And those were the distances, right? So if I were to take the distance of a leg, square it, add to it the distance of the other leg squared, that will equal the distance of the hypotenuse squared. Okay? We know that to be true, right? Later on in the year, we'll prove why that's true. But we're going to use this logic, this argument that we know that to be true, to allow us to come up with the distance formula. All right, so here's how we do this. If this number, x sub 2, was like 12, because that's all it represents, is some distance on the x-axis, right? Let's say it was 12. And let's say x sub 1 was 3. What would be the distance between x2 and x1? What's that distance? What do we talk, Hunter? 9, right? We talked about that the other day, right? We take the 12, and we subtract the 3, put in absolute value bars, and we get 9, right? What if this was 15 and this was 7? Do I do the same thing? 15 minus 7 gives me 8. Would we do that? Okay. Well, when it's x2 and x1, it's standing in for all of these real numbers that I could choose, like 3, 7, 12, 15, anything you want to think about. That's what the x2 and x1 stand in for. So instead of doing the subtraction with the real numbers, let's do the subtraction with the x2. I don't know what it is. It could be 12, could be 15, could be 100, could be pi, could be whatever it wants to be. Does that make sense? Subtract then from it whatever x1 wants to be. And that's what we would get right there, right? Now, just to guarantee that the distance is positive, I'm going to put absolute value bars around it. Does that make sense to everybody? Okay. The reason we'll absolute value distance always has to, we notice the length of that leg, and lengths or distances have to be positive, so you have to put absolute value bar. What about finding this red distance? So I'm looking at that red distance, that vertical leg, okay? You know, if y2 was 10 and y1 was 2, what's the distance between those? It's 8, right? Okay? Well, what if this was 100 and this was 25? Isn't that 75? And to get those results, ain't I just taking that number minus that number? So can I say this distance right here, which now I'm going to write it over here, is that distance right there the same as that one? If I transfer it out? Okay, so I'm going to say over here that this distance is the y2 minus the y1, and I'm going to take the absolute value of that. Okay, so that ends up being a length for that side of the triangle. So this here is your A side of your right triangle. This here is your B side of your right triangle. Does that make sense to everybody? Can I substitute that stuff into this formula? A, instead of calling it A, let's write it this way, x2 minus x1. But then they square A, so let's square that thing. B, instead of B, let's call it y2 minus y1. You know, square that. Now, C is the hypotenuse, right? That's actually the thing we're trying to find the length of, so we're just going to let it be C. And we'll leave it C squared. Okay? Now, we got a little bit of algebra to do. If I were to take a number and take the absolute value of it, what's the absolute value always do? Makes a number what? Positive, right? So regardless of what I get inside those absolute value bars, the result is going to be positive. Okay, now I'm going to ask another question. If I take any number like -5 and I square it, what do I get? Take -5 square it, what do you get? You get 25, a positive 25, right? Take 5 and square it, what do you get? 5 times 5. 25 again, right? Did it matter? I got the same product of 25. Did it matter whether I started with +5 or -5? That makes sense to everybody? So squaring something always turns your answer into a positive number, right? Absolute valuing something always takes your answer and puts it into a positive value, right? Does everybody understand that the absolute value bars here in the power of 2 in regards to the sign are doing the exact same thing? So one of them is not needed because they're redundant. Does that make sense? You guys know what redundant means? You know what redundant means? You know what redundant means? Hunter. What's redundant? What's redundant? Hunter, what's redundant? Yes, it repeats. Does the same thing over, right? Okay? So being redundant, these operations are redundant to one another. Okay? In some aspect. Now the power of 2 increases. It's a product. So I can't get rid of the power of 2. But I can get rid of the absolute value bars because the power of 2 does for me what the absolute value bars were going to do anyway. Does that make sense? So, and that in textbooks, that's not explained. But I want you to understand that I'm going to drop the absolute value bars because that power of 2 is going to do the same thing as the absolute value bars we're going to do anyways. Okay? And then here, get the same thing. Now, I'm solving for C. Right now I got C squared. So how do I get C all by itself? How do I get this to be C to the first power here? How do I undo a power of 2? Square root, right? So I'm going to square root both sides. I'm just going to flip things around a little bit. And it gives me x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now that's what C is. We redefine that and say, okay, our hypotenuse we're always going to call D for distance. But is that your distance formula that I had you copy down? What I want you guys to understand, because some people are going to mess this up, they're going to put the plus signs and the minus signs in different spots, is the distance formula the same thing as that thing right there? If I take a squared plus b squared equals c squared and solve it for c real quick, it gives me this, right? Where a is now that and b is now that, but does it remind me that this is a plus sign in between? So that there in between is a plus sign? Does that make sense, everybody? But I want you guys to understand those relationships so that if you get stuck on a test and you can't remember where do the plus signs go, where do the minus signs go in these formulas, because Mr. Fay doesn't give them to me, we have to have some ability to make an educated guess on where they come from. And if you can understand that logic, that the distance formula is just a Pythagorean theorem. That's all it is. You've been doing the Pythagorean theorem since you're like 5th grade. We're not doing anything new here. Okay? So I want to do a question, and this is going to be pretty easy, this first question here. It's got 2 points here that I want to find the distance between. Always write your distance formula down. And we'll talk a little bit more about this tomorrow and some alternative versions of the distance formula we might be able to write. Okay? But if I've got u to be -7, 5, and I've got v to be 4, -3, I always stack my ordered pairs when I'm going to use the distance, or if I'm going to use the slope, or any other formula, like maybe even the midpoint. I stack my ordered pairs because when I do subtraction, okay, I can just subtract my x's straight down. What's -7 minus 4? -11, right? So that thing turns into -11, and I'll square it. What's 5 minus negative 3? 8. And I'll square it. And now I can do the work. Negative 11 squared, 121. 8 squared, 64. It's going to give me a distance eventually to be radical 185. We'll talk more tomorrow about what we do with that radical 185. Okay, I think in all your homeworks it's going to ask you to type in your calculator and round it. Okay. But now think about this. What if I would have reversed it? What if I would have found the distance? That's going from U to V and found that distance. So it's like going from this edge of my desk to this edge of my desk and finding the distance, right? If I go from this edge to this edge, should that be a different distance? No, it should be the same, right? So what if I go from V to U? What if I go 4 minus negative 7? What's 4 minus negative 7? Careful. It's positive 11. But think about squaring it. If I square positive 11, do I still get the same thing that I got when I squared negative 11? Still get the 121, right? So the order that I subtract them doesn't matter. If I go negative 3 minus 5, now I get negative 8. But if I take negative 8 squared, do I still get the 64? So when you do subtraction of your x's and your y's, it doesn't matter the order. Okay? Now, you guys have dealt with slope a lot last year, right? y2 minus y1 over x2 minus x1. Is that the same components for slope? Isn't slope your rise, your vertical change, over your run, your horizontal change? And when we did x2 minus x1, we just found our horizontal change. When we did y2 minus y1, we did our vertical change. So when you found your slope last year, you were finding all the parts that you needed to find the distance as well. Okay? So a lot of times when we're doing this stuff, and we'll use this throughout the year, there will be two things that they ask you in the problems, distance and slope. Okay? And I hope that you don't do the calculations twice. I hope you do slope one time and then use that information to help you find distance. Or do distance one time and use that information to help you find slope. Okay? We'll talk about more examples like that tomorrow. I've opened up an assignment for distance on Math Excel due tomorrow evening at the earliest.